Okay, we are in week 7. And I'm going to go ahead and get started. And 6.16 was first, 6.18 was second, and we're at 8.15 with number 4, 9.5 number 3, and number 2 is 8.8. These are the numbers I gave you. So far, unless somebody else comes in, Blake, 3. I'll be bringing more of those too. We're printing a whole bunch of those out. So I thought it'd be something fun to do.
What is it?
Huh? It's a phone stand. So you put your phone on there and it'll stand up. I've got one more. I'll do one maybe at the end of class. We'll get rid of that one too. All right, cool. All right, so here we go. So week 7, discussion and exercise. Let's go there. We're going to cover first regular expressions or regexes. We'll do a little in-class exercise on that, and then we'll discuss your and go over some slides on for your take-home. What that's about. We're starting version 2 this week of your shopping list application. So regular expressions. This link here goes to the book we're reading, text on regular expressions. If you've not read that, definitely it's a good read on what regular expressions are and how to use them. Basically, in a nutshell, regular expressions are used to test or validate input. Okay, so validating input would be like email addresses. Make sure they're the correct, letters, an @ symbol, a domain, a dot, and a name, a dot, and a domain. That type of thing. Making sure the format pattern's correct. Same thing with phone numbers. You can do regexes. Any type of input you can create your own regexes for, by the way. Tonight we're going to do regex to determine if a string starts with a capital letter in the in-class, but there's literally hundreds and hundreds and hundreds and hundreds of regexes, if not thousands, that you can create. Basically any input that you can, we talked about this a couple weeks back, when you're debugging, one of the things you're doing during debugging is determining what are some things users can put in this field, and regex helps you delineate and tighten that scope, if that makes sense, to where you only get exactly what you're asking for. And there's no question on the end user either on what you want, which helps tremendously. Because the one thing you don't want to do on a program or an app is, even like on the shopping list, is if, say for instance, we only wanted letters only, which this one lets us use anything, but say we wanted only letters only, we could create a regex for that. To do that, to validate letters only, no numbers, no special characters, things like that. Banking websites, even your any website that has a registration form generally uses a regex to determine the format of your password. So like in a bank website might say you need a caps letter, you need a special character, 2 numbers, wherever, and it's got to be at least, let's say, 10 characters long. A regex is what determines, validates that and tells you whether or not you've met their criteria or not. And you might have even seen some websites do a pretty fancy job of, as you type in the password and fulfill the regex, it'll actually checkbox the different parts of that password that you met. You've probably seen stuff like that. So that's a regex that does that. So read the text if you've not done so. We're going to start with a slideshow we're going to go over on this Web233 slideshow. And there's a couple references, a whole bunch of references actually, because regexes are pretty powerful, but they can be kind of confusing when you first look at them. But there's a lot of great resources to help you on figuring out what a regex is, how to declare one, how to use it in your code. And so that's why I gave you so many references. There's so many good references out there. Some of these references, by the way, not only tell you what a regex is, but it gives you validation to where you can create your own regex for your own app. And so we'll look at these after we look at the slideshow here. And this should pop up a PDF I put together for regular expressions. And what's cool about regexes is they're pretty global and universal. amongst all languages. And so we're doing JavaScript in here, but we could use the same regex for any language. It could be applied to PHP, be applied to Java, it could be applied to C#, C++, Swift. Any language uses the very same regex code, okay? It's how it's declared and used, but the code doesn't change. So that's a nice thing. Okay, so this slide talks about history or some of the, let me see if I can bring this down just a little bit to bring everything in there. There we go. So Java, influences on JavaScript, we've got like basic syntax, many type method names, scheme of JavaScript, functions, closures, dynamism, self, which is prototypal inheritance, and then Perl, regular expressions. What this means is these are influences JavaScript has had upon creation of JavaScript. Those that developed JavaScript, the two Illinois university students that created JavaScript years ago, before the invention of Mozilla browser. And so these were the influence back then, because guess what, that's what was taught in school. That's what coding was taught back then. Java, Perl for sure, and Perl had regular expressions. It does have regular expressions. So a historical note on Perl, it was like flawed, horribly flawed, a very useful scripting language, but based on Unix and C, and it helped lead the way to many other languages like PHP we've got today, Python, Ruby on Rails, list goes on and on, all the different languages, based upon Perl. And Perl is an old language. It was excellent for stringing files, text processing, had built-in regular expressions directly into the language as a first data type, class data type. And JavaScript wisely stole this idea verbatim from Perl. So if you've ever seen Perl or worked with Perl or played with Perl, you see a lot of similarities in regular expressions you'll see tonight from that. So here's an example of a regular expression. Beginning / tells you you're getting ready to start expression. Everything in between that is the expression and then the end expression. So beginning expression, end expression, which is these two tags here, the / and then everything in between is the syntax or the pattern of the text needed. So regex describes the pattern of text. It can test whether a string matches a certain pattern. It can use a regex to search and replace strings within a string. Very powerful, but as you can see, without knowing anything coming into it tonight, maybe very tough to read or understand just by looking at it. But once you understand how things work and some of the symbolizations and brackets and things, it's pretty easy to wrap your head around. You'll see tonight by the time we're done, hopefully. Regular expressions occur in many places. Text pads, an example, allow regexes to be put in by searching and replacing for them. So you can literally type in email, web, things like that, and it'll give you back a regex to use for a number of languages with examples. JavaScript, like we're using this semester, Java scanner, string split, Unix, Linux, Mac shell commands. Some of those commands are like grep, sed, find, etc. These are the ones I actually started with using years ago on the scripting. And we do have a class here on campus, some of you might have taken, on Linux scripting. Anybody taken that with Charles? It's a really good class. Anyways, mainly in that class you learn Linux scripting and commands to create files, folders, upload files, folders using PuTTY, and hundreds and hundreds of commands that they go over in that class. Still used a lot today in programming and manufacturing, and good class to take. If you have three credit hours you need to get, Linux scripting would be a good one. Recommend it. He's been teaching for I've been here almost 20 years. He's been here maybe going on 30. So, and he does this for the day in his day job. Yeah. Linux scripting. Linux scripting. Let me see if I can pull it up here on the screen. I don't know if they're offering the fall or not, but I recommend taking it. I'll just do a search here real quick for sections. We'll try. We'll see if it's offered last fall first. It might be a PCT course. No. Let me see if I can do. Let's put script in the course title. There. Yeah, that's me. Oh, maybe it hasn't been offered a couple semesters. I'll find out what it is, what the call letters are. But it's Windows, it's a Linux scripting. I'll find out what that is and post it. But it is a good class. I know he's going to be offered, I believe, in the fall. And I'll find out what those call letters are. But anyway, getting back to what I was saying, scripting is something that's used quite a bit still today in command prompts. Some of you are more familiar than others, maybe with command prompts. Anybody any command scripting or scripting of any type before in your work or in your programming? Where you've done maybe DOS commands? You ever heard of that? Where you can create folders, files? I know you have. And that's why I started with. I know you start with. Any file management was always done in commands. Until Windows GUI came around. But it's still used a lot today. The reason I mention that is scripting is still used a lot, and you'll see that in Regex. So here's some methods of Regex that can be used, like match, returns a first match for a string against a given regular expression. If global, there's a global flag that can be used that returns an array of all matches, and we'll see this again as we go in the examples tonight. Replace two arguments, the regex expression and the text you want to replace. So replace the first occurrence of the regular expression with a given text. If global flag is used, it replaces in all occurrences. Otherwise, what it's going to do if the global flag isn't used, it only replaces in the first occurrence it finds in the string. Search returns first index where the given regular expression occurs. Split with delimiter, comma, limit, and brackets. This will break a string apart into an array. So if you're given in a program, you suck in a file that has like a CSV file with a whole bunch of commas in it. This is good to use. A split's good to use because it'll take those commas and put it into an array, all the items into an array. So I've used that a lot when I'm bringing a file in from a website or a program, and I'm wanting to bring it into a program, whether it be JavaScript or other program. The split will help me create an array of that file content to use within my program. Okay, so that's a popular one. ABC basic here. Again, beginning and ending of the regex. In the middle is the argument or the pattern. So a regular expression, literal in JS, is written like that. Beginning, the pattern, and ending. Okay. The simplest regex simply match a given substring. So the above regex matches any line containing ABC in lowercase. Okay, that's what it does. That's all it does. So an example here, yes would be returned if this was a string, this was a string, this was a string, or this was a string. Does that make sense? Because the ABC's in there. No would be returned if these were the strings, because none of them have ABC right in a row. This one has ABC in it, but notice there's a space, so it wouldn't work. Make sense? It'll make sense. Hopefully the mud will be clear as we go on. Next, a dot operator. This is used a lot in programming. And regex is used for wildcard. So it matches any character except for the new line character. /n /.oo.y matches doocy, goofy, loopy. Make sense? So see, dot, dot, there's the D, the C, the G, the F, the L, and the P. All global characters, right? A flag or an asterisk type of thing. So matches any character with a dot operator. Using the \dot, this is to literally match a dot character. So if you're going to use a dot, you have to do the \dot. You have to use a dot, which you're going to use that like in an email regex, right? It has to have a dot in there for the domain. So rockefellercollege.edu, abc.com, yahoo.com. The caret here, or it's actually the technical word for that is end caret, I believe. Yeah, end caret. End caret, and that is, by the way, the shift 6 on your keyboard. So number shift 6, you'll get the end caret. It matches the beginning of a line. We're going to use this one tonight, actually, the end caret. It matches the beginning of a line. The $ matches the end of a line. So this one here would match, the if would match lines that consist entirely of if. Because notice that here's the beginning, the end caret, and here's the ending. So the match of the line that consists entirely of if, meaning if only, could be on that line. That's it. Now, if we took the $ out, it would mean strings that start exactly with I and F, lowercase. It would match. \lesser than demands a pattern is the beginning of a word. \greater than demands pattern is the end of a word. So here we have an example here of beginning, ending, regex. Then we have the \lesser than, which demands the patterns at the beginning of the word. For. Then we have \greater than matches the word for only in that one. For only on that line can be because of the beginning of the word and the end of the word both. Nothing else can be in there but for in that word. String.match regex. If the string pattern fits pattern, it returns matching text, else null. It can be used for Boolean truthy falsy tests. So if name.match A to Z get true or false, so it means if something in the text is A to Z, lowercase, it's going to come back true. G is after the regex for array of global matches. I like to compare this one to when you guys do like a find and replace or find and replace all in like a Word document or some type of text document where you're searching for text. That's what the G does. G would be like find and replace all. If you want to replace all the periods with a comma or whatever the case may be, that's what G does. It globally returns everything. So Obama.match.a/G would return BA and MA both, because A is in BA and A is in the MA. So return a global match of all. Because remember this dot operator, remember that's a wildcard. So it could be any letter, and you need the letter A. And because the /G is in here, or the /G, it's going to search the entire word and return everything that matches this pattern. Remember, this means wildcard, any letter. This means A, lowercase. So we have two matches, BA and MA. Make sense? I is after the regex for case insensitive. This is going to be used a lot of times, again, on input for users, and they do this for usernames a lot on a database. Because when people type in a username, generally the database doesn't need a username to be a certain syntax, right? If you're my username, is like cconk a lot for accounts. So I can put in all caps cconk, lowercase c, uppercase KONKOL, and most all databases will let me log in with that because of using this insensitive match. Because most of your databases could care less on username matching of syntax. They do care less though on the passwords. So you wouldn't use this for passwords. So if you're just using a certain search for a word in a text, this would be good. The insensitive match would be good. Where you want to find all instances of the word "the" in a story, or all instances of the word "complaint," or all instances of the word "whatever." You would use a case insensitive because the user would type in "whatever" for the search key, hit search. Case insensitive would be the best way to use that. So on this example, name.match, Marty with /I would match Marty lowercase, Marty, a mixture of lowercase, uppercase, either one. String.replace, this is used a lot in programming, where you want to take a certain string and replace it with something else, okay? An example for that would be in school, if I have a list of everybody's S numbers and I want to replace your S number with the S with some other letter, like say a T, I could do that, or a B or whatever I want to do. That would be an example of replace. So string.replace, the regex itself, whatever the pattern is, then the text. So replaces the first occurrence of the pattern with a given text. You can use a global. It will replace all, which would be the G one, the /G. So an example, if we had a variable called state, had the word Mississippi in it, and we did the state.replace, beginning variable declaration for the regex, S, and, so we're just looking for the letter S, or that's the syntax of it, looking for the letter S pattern. And they give the pattern of X returns this. It replaces X every time it sees S. So, and actually in this case, just the first time because we didn't use a global. If we use a global, put the G in there, you'll notice it'll replace every S occurrence with X. See that? So just by adding the G after the regex, we'll replace all. So if we want to do the same here with, like say we did I instead of X, it would do that. It would replace, if we took I and looked for S, all these S's would become I's. It'd be just basically all I's, except for the last two PBs. Sorry. Which you would never do that, but anyway, you could do that. The bar sign means or, and that's a lot of times used that way in programming. You've probably seen that. So if we did ABC or DEF or, and then the global, this would match the lines with ABC, DEF, or G. Take it back, that's not global, that's G. ABC, DEF, G. So an example here, next is precedence, subject, or date, versus or subject date. They'd be looking for that pattern maybe in a string. There's no end symbol. No end symbol whatsoever. Why not? Because that's used basically, you're basically never going to return back, more likely, on that. And so the parentheses are for grouping. So if we want to group Homer, Marge, Homer or Marge, and then Simpson, matches lines containing Homer Simpson or Marge Simpson. Okay, so it'd be first or second. Starting, this backslash starts an escape sequence. Many characters must be escaped, like a dollar symbol, period, left right bracket, left right parentheses, the end caret, the asterisk, the plus, the question mark. Backslash n, backslash n matches lines containing backslash n. which a lot of times in programming, when you're bringing files in, that will be used a lot for new file or new line occurrence in a text file or a CSV file a lot of times. Mean 0 or more occurrences on the asterisk. So an example would be if we did ABC asterisk, this would match AB, ABC, ABCC, ABCCC. A with BC in parentheses would match A, ABC, ABC, BC, ABC, BC, BC. A dot asterisk A could match AA, ABA, A8, because remember the asterisk or the dot is a wild card. QA, A exclamation point, question mark, underscore A. So meaning one or more occurrence, the plus symbol. So A, BC, parentheses, plus would match ABC, ABC, BC, ABC, BC, BC, BC. Google, the Siri's going crazy here. Google just thought I said, can you sing please plus one match? ABC, ABC, ABC. No, Google, I don't want that. Thank you. All right. Okay, turn that off. So GOO plus GLE would match Google. Google with 3 O's, Google with 4 O's. Again, because a plus symbol to the right of the character will give us more than one occurrence. Question mark means only 0 or 1 occurrences. So Martina with a question mark matches lines with Martin or Martinet. Daniel, question mark, matches lines with Dan or Daniel. Min-max, other quantifiers, simply between min and max occurrences. So if we had A, the character string has to be starting with A, can be B or can be BC, 2, comma 4 would match lines that contain ABC, BC, ABC, BC, 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 and then ABCB, ABCB, CB, CB, CBC. And again, this is min and max occurrences of a matched character, which would be those three actually right there. Min or match can be omitted to specify any number. So 2 or more, up to 6, or 3 exactly. So this is when you don't want to use a global, what you might want to just define how many. And this would be an example, I guess, on search engines. I know it's an example on search engines, like on Google. When you search anything on Google, it only shows you the first whatever n number on the page, right? So say if there's 1 million returns, it's only going to show you, let's say, 100 on your web page. Could it show all 1 million on your web page? Yeah, definitely it could. If you wanted to, if it programmed it to, it could definitely do that. But it limits it to the first 100 just to help with processing and things of that nature. You don't need to show all 1 million. That's why they hit the next button and it goes to the next 100, the next 100, the next 100, the next 100, so on and so forth. So that would be the show up to 100. Might be an example on a search engine like Google, or 1,000, whatever it might be. The character sets are starting with the left and right bracket. Group characters into character sets. They'll match any single string or character from the set. So an example of a character set, BCD, and then art, matches lines with BART, CART, or DART. Makes sense, right? It's equivalent to the OR, but a lot simpler, and you don't have to type as much in, right? So it's just a little shorter. Inside the brackets, most modifier keys act like normal characters. So if you needed, for instance, on the end of a what statement, a period, exclamation, asterisk, question mark, and you wanted to search for only that, you could do that. It would match what period, what exclamation point, what question mark, and what question mark, asterisk, asterisk, exclamation point. All right. Inside the character set, you can specify a range of characters. We'll be doing this in a second in the in class. Like if we wanted to do lowercase only, A to Z, there you go. If we want to do any letter or digit, A to Z lowercase, A to Z uppercase, 0 to 9. That would give us every known letter and number that we could ever need. The end caret, an initial end caret inside of a character set negates it. So it matches any character but, in this example, A, B, C, or D. All right? And by the way, if we move this character, this end character outside of the bracket, all right, it would match a string that starts with A, B, C, or D. All right? But inside of it, though, it negates it. Any character but that. It's kind of like in programming. A lot of times you'll see if a statement's not equal to, which in programming, when you're first learning programming, that can be kind of weird because you're like, okay, why are we doing that? It does make the loops a lot less a lot of times when you do the not operator. It delineates a lot of junk. So that's why it's done this way a lot of times. Inside the character set, the negative sign must be escaped to be matched. So, or the minus sign. So here's what they're talking about right here. See how it has the escape character before it. So in this example here, we can have in the character set a minus or plus, question mark, 0 to 9, plus. What this would match is an optional minus or plus, followed by at least one digit. And any digit that could be 0 through 9. Okay? So it could be doing that there, matching phone numbers, yada, yada. Would be a good example. So built-in character ranges. There's a whole bunch of built-in ones that you can use in regexes. /B, \B, word boundary, space between words, \B, uppercase, nod word boundary, /D, any digit, 0 to 9. It's equivalent to 0 to 9, so a lot of times you'll see that in regexes. It's a lot shorter to just do \D than bracket 0/9 bracket. Just a lot quicker. \caps D, any non-digit, equivalent to the end character 0 to 9. So not 0 to 9. What would be a non-digit equivalent? Would a letter be a non-digit? Would a question mark be a non-digit? Would an asterisk be a non-digit? Yeah, it would, right? So anything that's a non-digit, meaning anything non-0 to 9 would meet that /D, \D. \S, any white space, and lowercase s, by the way, any white space character, okay? Any \S, uppercase on that one is any non-white space character. Any word character, \W, lowercase. Any non-word character, \W. And the ones to the right, by the way, are what you would do long term if you were to do it without the \S. You'll do all of these here. Any word character, instead of typing all that in, you can just do this \W. So the ones to the right are just showing examples of what you do if you did use the short built-in character ranges. I do recommend learning these and just bookmarking. You'll see some bookmarks I gave you tonight that you can bookmark on your devices to help you. Then \XXX, XHH, and \UHHHHH. This is for the given hex and Unicode character. That maybe there might be cases where you use that in some programs, possibly, where you want to do hex and Unicode characters. Here's some flags. We've already talked about one. Global, the G. Case insensitive, the I. Multi-line mode, the M. We've not talked about that one. It just basically do multi-lines of checks. Y is sticky. The search from a given index. And I'm going to stop there. I want to go back to the main discussion page. And now I want to click on the first link here under resources. We're going to look at the first two because that's going to be pertaining to what we're going to go over tonight. I would recommend looking at the other ones to help you. There's like a one here on JavaScript tutors that goes over some more examples. All these down here give good examples as well. But we're just going to go over the first two. The first two are from W3 Schools. The first one here is on the JS ref object regex express. So it tells, this is basically the reason I'm showing this, is it kind of gives the JavaScript official reference on regexes. So it says here, regex expression is an object that describes a pattern of characters. Regular expressions are used to perform multi-pattern and search and replace functions for the most part. We've already went over this, but you have the /, the pattern, / and any modifiers. Modifiers would be like the G, the I that we went over. Okay. An example here is W3 Schools. What would the I be? Anybody remember? Insensitive, right? Case insensitive. So it doesn't matter how you type it in. It'll be case insensitive. So as you scroll down here, I want to look at some of the modifiers. We've already went over these, but I is case insensitive. G, performing a global match. M, multi-line match. If you click on this multi-line match, click on that one. I'll click on it. You can just look at the overhead. Basically, what this is referring to is when you do a multi-line search for is at the beginning of each line, that's what this refers to. Okay. If you wanted to do something like that, it would. I'll show you on the test here. So we did a multi-line match using the M operator, looking for the word is. In the click the button to do a multi-line search for is at the beginning of each line in the string. So it's only going to find one there because that's all it's found there for the string pattern. Is this is, and it finds it actually right here on this one right here, so it returns that one. If we had another one here, and actually that's a \n, so I'll put another one in here. Is I gotta put the it's only going to give me one back, so I don't have the global on it. No, it won't work with global, and that one will not work together. So it's only going to give me one back on it. Okay. So that one's basically for multi-line. Again, doing a multi-line search for is at the beginning of each line of the string, and it's talking about this here. Now, since this is not case insensitive, it's only going to return this one right here. And the /n will be the new line function it's referring to. Brackets, we talked a little bit about that, but brackets A, B, C would be find any character between the brackets. The nchar, find any character not between the brackets. 0 to 9, any character between the brackets, any digit on this one. Not any digit on this one, or find any alternative X or Y. And then meta characters, special meanings, we already went over those. Quantifiers, I will stop on this one. We're going to use this quantifier here, which is the n. Matches any string with n at the beginning of it. All right, so I'm going to stop there. And I want us to go to the in-class lab, 20 points. And the first two links is what we're looking at. And I'll bring the second one up on the overhead because it refers to what we're going to be using tonight, the regex nchar identifier. So just didn't put refresh that. it's not in there. So if I did here, for some reason that's not refreshing to that one. So I'm going to do something different here. I'm going to do a left bracket just to show you, and we'll do, let's see, we'll do the letter, we'll do ABC. ABC is a pattern we want to use. Pattern case. Oh, I forgot to put my character in there, sorry. Okay, so I'm going to put in this one. I'm going to do, let's see, I'm going to use the end care for this example before we go to our end class. End care, and let's do ABC in brackets. And you can just watch me do it on this one here, and then end line, that should work. So what this is going to do is anything that starts with ABC is going to return lowercase. Nothing there. So let's try, let's see, boom, 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 uppercase ABC. Run it. Nothing there. And let's try, let's see. Lowercase a to z, uppercase a to z, this is is, uppercase a to z, should be it, pattern, demo,
Is the variable string supposed to have an end?
Do I know?
Variable string, is this it? Is it supposed to be an end in there?
Supposed to be an end where?
Where the recovery?
No. Let me just replace this string altogether with something else. I'm going to put in there, let's see, at the movies or something. Might just be this browser's not refreshing it too. There we go. I don't know what was wrong with it. But anyway, so I got A to Z uppercase. Now if I change this lowercase A to Z instead of uppercase A to Z and run it. Yeah, it's not coming back because, again, it's the start of a string has to be A to Z lowercase. So I'm going to change it to that. And it can be any letter, actually. I can do Tonight at the Movies with the caps T. Tonight at the Movies, run it, returns T. Make sense? So I got to work there. All right, so you're hopefully at the Replit, and we're going to, you need to log in as always, go to Lab 7. And what we're going to do, we're going to do this together. I do have a handout I'm going to give you in just a second, but we're going to try to see if we can figure it out without the handout first. I'll try to help you out. So on the right is the instructions. The first thing we're going to do is write a program to test. This program writes a program to test the first character of a string is uppercase or not. We'll create a function called uppercase that takes an argument str. So here's the syntax for a function called whatever the function might be. We're going to call it uppercase. So in place of name, it will be uppercase, and the argument in place of that will be str. So we're going to write that on lines 2 and beyond. the new function. So it's again, function starts with a lowercase f, by the way, not uppercase. And it's upper underscore case, left parentheses, str, right parentheses, hit the return key, and then we'll do a left bracket or left left beginning bracket for a function. And that's what it should end up looking like there. That's a little bit bigger, right? So we created our function called uppercase. And next, number 2, inside the function, we need to create a variable named regex with this expression needed to catch the strings. On what the string we want to catch is only a string that catches that starts with a caps letter. And I already done the example earlier. So on line 4, if I'm going to declare a variable, what do I need to start this line with? What 3 letters do I need to start with? var. So it's going to do that. var space, and I already gave you the name, regex, R-E-G-E-X-P, equals, and then here's where we're going to do the expression. And on the expression, it starts always with what character? Remember, it starts and ends. You remember? Yeah, it's /, so we'll do a /. And we said this one needs to start with first letter has to be capitalized. And we're going to use the example we did earlier. And what special character was that? Yep, the caret, the little end caret. And again, that's a Shift 6 on your keyboard. On the top row of your number key, Shift 6. And then the range is going to be uppercase only, and it's letters. So what range should we put in there? We want all letters included, caps. Give me any letters. What range would it be? There you go. Brackets, A to Z in all caps, and put a dash in between the A and Z. So A, Z, right bracket. Nope. That one. And what am I missing now? What I've left to put? 2 things I have left to do on this line. I've got my end care. I've got my range, A to Z, uppercase. What is it? Yep, another slash. And then what else I've left on every line on JavaScript? You got to have these pretty much. The semicolon, put that in there. So I've got my regex declaration for my test. Next, I'm going to put an if statement, an if-else statement that will test the regex of a string. And if it's true, it's going to show string's first character is uppercase. And we'll do a console.log on this. If it's false, string's first character is not uppercase. So start with the if statement. The name of the regex, regex P, and if statement should always start with a left parenthesis. Sorry about that. Regex P dot, and we're testing this regex, so it's dot test, and then the name of the string we're testing we're going to get from the function. And what 3 characters is that we brought into the function? What's the 3 characters? And it's in parentheses and the function name? str. There you go. So that's what we're going to test. So we have regexp exp.test str in parentheses, end parentheses. Then we're going to have a new line, left bracket, hit return. It'll create the right bracket for us. And here is going to be true. If it's true, meaning the string we send to this function in a second is uppercase, starts with uppercase. This is a true statement. We're going to do a console.log. And we're going to put in parentheses and in quotes what I have over here, which is strings, first character is uppercase. So we'll type that in. Is uppercase. Semicolon on the end. Now, that's the if path. That's if it's true. Next, we got to put a return key, or we could just type in else, left bracket, return. That would work as well. Or you could do return else, left bracket, return, either one. And here we're going to put the second false path. Strings first character is not uppercase in a console.log. So it should end up looking like mine. We have our if path, which is a true path. It's going to kick out this line. If it's false, it's going to kick out this line. Everybody got that? We're still working on that. Once you've done the test for the if and else statement for the regex test, we're going to create at the bottom on line 12 and 13 a call statement to the uppercase function. The first call statement will have a string in there if you're choosing that starts with a caps letter. The second string, I want it to start with a lowercase letter. It can be the same string, but just make sure and send it to the call to the uppercase function, starting on line 12. So if I call a function, do I have to include the word function or just the name of the function? What do you think? Yeah, just the name. Yeah, just the name of the function. So uppercase, upper underscore case, and then I'm pushing an argument to uppercase. And so what do I need to put to the right of uppercase? What do I need to put where my cursor is blinking? Do I need to put a left parentheses or a left bracket? You think? Left parentheses. Left parentheses. And then in single quotes, you're going to put whatever string you want to send it. And this one, I want you to put the uppercase letter, regardless what the string is. Make sure the first letter is uppercase. I'm going to use my example earlier at the movies. And make sure to put a semicolon on the end of that one. I'm going to do another call to the uppercase again. And I'm going to use the very same string, but just change the at from uppercase to lowercase there. Then run it. And see what happens. Should get back on the first response. Strings first character is uppercase. Should have hit the true path. I put you put the caps letter in the first part of the string, first letter of the string, and then the second one should have been starting with the lowercase, which says the first character is not uppercase. Now to test that, you can flip it, so I can get rid of put the caps A lowercase on the first one, and the caps A on the second one. Change it, just flip them around, run it again. Okay. And so we've literally created a function that had a regex to get a return value for that function. So we basically searched a string with a regex, and here was our regex. Any character, any uppercase character, A to Z, that begins with any string that begins with uppercase character A to Z is going to return true. True if it starts with a caps letter. False if it doesn't. Make sense? Now go ahead and submit that for me if you would. Go ahead and submit that. And back in the Web 7 discussion and exercise, put the word done. Submit the word done in that text box entry so I'll know to go back and grade that. And that would be great. Questions on that Regex exercise? Again, just a simple search and finding information. And I did have a handout for that. I'll give you, you might keep it just for if you have a notebook, you keep your stuff in or whatever. I thought it'd be good since Regex is kind of tricky when you're first learning it, so it might be helpful to keep this in your computer bag or something just so you, if nothing else, see the syntax layout for Regex. And I use ABCD, but you use whatever you use, that's fine. All right, so let's go ahead and hit next on our week 7. For next week, as far as reading, we'll look at that real quick here. Close some of these browsers while it's doing that. Okay, week 7 is document object library from our text. This one actually is where we'll start getting. The reason we need to go over this is as we start creating the different versions of our application, we'll begin needing to wrap it into the HTML of the document, and that's what this piece talks about. And specifically, it's talking about the DOM of the DOM, I'm highlighting on the overhead, the DOM of the web page. Okay, the DOM of the web page is the document node, the DOM node, to where you basically can take advantage of in JavaScript every tag and even create your own tags to determine where you want it to go on a web page using the document tag. So it's actually, you'll learn this reading for next week, and we'll cover in our in-class document dot whatever. And that dot is actually built-in tags for HTML plus custom tags you can create as well to call to. And we've already done that a little bit in here the first few weeks, showing you some DOM hooks. But you'll learn more about some of those DOM hooks, built-in DOM hooks, built-in element tags, and custom element tags. So it's an important one to read. As always, go over when you see text in the log, do the Control-Enter thing to have it run in there, like this one just did. This one talks about document.body book, and found it and came back with true. All right, so read that. Go over the examples. The week 7 assignment I'm going to get you started with, so you'll know what you're doing, and then you can do this on your own after class. It's kind of like we did last week. I did the same. I'm going to keep on the same building your app. This week, though, with version 2, you will be starting with a brand new plunker because you're going to be using functions, all new functions. It's the same code you've been using for the declarations of things, but we're using functions only, building on kind of what we've been doing with functions. So if you click on this View and Complete link, it'll bring us to a slideshow. I want to go over it real quick, see if you have any questions on it. So this week we're starting with version 2 of the shopping list app. And the requirements are to keep track of everything to make sure we stay on task. I was just in a meeting today with some programmers and non-programmers, and people were getting way off on left field on different things. And somebody in the meeting said, hey, let's get back to task, what we're working on. Because if you've ever been in meetings before, some of you have, where people try to just start going over here. And not to say those things aren't good in and of themselves, but an hour meeting becomes a 2-hour meeting or a 3-hour meeting. And I don't know about you, time's pretty precious. Let's stay on task and get it done, and maybe set up another meeting for the other ones that you have that's important, possibly. So this will keep us on task. You'll notice the word change in this one the last 2 weeks is the word function. We're going to have a function to display shopping list, a function to add a new shopping list, a function to change a shopping list, and a function to delete a shopping list. So same methods are going to be used, but we're using functions this week, starting to use functions this week in our app versus just calling it and adding it in an array. So the last 2 weeks we completed the main foundation of the app. This week we'll start automating the app with functions. And as we saw tonight, we could keep calling to that function we created tonight with that regex multiple times in our app, regardless where it's at. We could call it within our code to be used. So you'll create a new plunker. You don't want to do it right now, but I want to go over this first. You will create a new plunker. You'll save it to shopping list version 2. Change the H1 tag to shopping list version 2. Move the JS script below the H1 tag like we have been doing on this one. Because the reason we're doing that is we want it to show up after the title tag runs. So an intro to functions. Functions like recipes. I was a chef for years, and so I still like to cook a lot, as you can probably tell. I like to eat too. And so for function like recipes, it takes a long list of instructions and gives you some result. To understand it, we'll start with making a turkey sandwich and convert it into a function. So we have make turkey sandwich, get 1 slice of bread, add turkey, put a slice of bread on top of it. Pretty simple. So hopefully by now you know the syntax for function, but I want to put it in here. Creating a function, the word function, big or not big mistake, but the most common mistake is the word function. It's always lowercase. Then the name of the function should make sense to what the function does. All right. So this one's make turkey sandwich. This is an open bracket, meaning there's no arguments sent. So anything loaded in this function will run, and only within this function. So it doesn't take any arguments outside of this app. So get one slice, or get outside this function. So get 1 slice of bread, semicolon, add turkey, semicolon, put slice of bread on top, semicolon. Now again, if we ran this in JavaScript, it would blow up. But again, we're just showing what it does to show you visually what it does with pseudocode. It would give us a lot of errors if we ran it. So finally, we create the function, then we call it with just make turkey sandwich. All right? Makes sense, right? But say we want to customize it. We want to customize the recipe now for repetitive recipes. We want to use it over and over again. For example, making a turkey sandwich or a ham sandwich is pretty similar, except for the filling parts. So a good situation where we could tweak our example might be make your sandwich with whatever meat, get 1 slice of bread, add that with whatever we put in there, ham, turkey, chicken, whatever we want to put in there, beef, sliced beef, roast beef, then put a slice of bread on top. So JavaScript for this one, notice we added filling in the function. So function make sandwich with filling. So get slice of bread, add whatever the filling is, put slice of bread on top. To call it, just like we did earlier, call the function. On this one, the only one you'll comment a lot is folks will get errors if they don't type the same syntax that the function was created in, uppercase and lowercase. Has to be the same or it won't work. And you probably know by now JavaScript is pretty silent in and of itself in its errors inherently. Now, we showed you in week 1 and 2 how you can go in and do the Chrome debug, which you can definitely do to find out those errors. But this is a pretty simple one just to remember. Syntax the same for all your functions throughout. Next slide. So now we're going to start creating in your app. You'll start creating the first function, which will be the first requirement is to display a shopping list. So shopping list, you start with item 1, item 2, item 3. Bare shopping list, item 1, item 2, item 3. Then add a shopping list called display shopping list. Write that list out. Then call it. And again, we're calling a shopping list we've created or a function we've created here that doesn't have an argument, so just going to write to the web page, and that's it. There's no other input. So we've literally fulfilled that one. And again, what I'd like you to do is, I know from last week, I think I had you guys create 3 initial in the code and add 7 or something like that. You can do the same with this one. I'm just showing the bones of what I want you to do for version 2. So if you already have, instead of items 1, 2, and 3, whatever you used last week is fine for your app, okay, whatever you put in there for your default 3. Then adding a new, you're going to create a function called add shopping list and do the push statement just like you did in weeks 1 and 2. And you'll add an item. I only have you adding in right now, as you can see, 1 item, but you can go ahead and add in as many as you want to and play with it. I think, you know, if you want to do the same as you did last week and add 7 pushes in here, that's fine. But wait, and you'll see why. I'll tell you wait in just a second. This will be the function you want to probably create to use if you're going to push it multiple times, because this function here is different than this function here. The add shopping list item only adds 1 shopping list, and you have to hard code it in, right? This one will take an argument, take an item, add it to the shopping list each time it's called, and display that updated shopping list. So it's going to add it and display it each time it's called. So when we run this one, this add shopping list items, you're going to add that manual add item 4. Display shopping list would display them again. But if we did add item 5 using the add shopping list function, it's going to add item 5 to that function that we created, which was this one right here. This one right here that takes the argument. So what you can do on your app is on this line here, instead of add new item 5, you can do add whatever the 7 items you added last week, you can add them here. Just add them 7 times. Just add shopping list 7 times, and whatever items it is you added, you can do that. So that fulfills the adding new shopping list in a function. Next is adding changing the shopping list. For this one, basically you're taking a function, and we're calling it change shopping list. You need a position of the array and what the new value is for that. Position, new value. And remember, in functions, you can give it whatever arguments you want. This one just has 2, position and value. So shopping list position would be, let's say, 0. The new value, maybe we do update item 1 is what we might do, or change item 1, and then display it. So if I call that, that's what I'm doing right here, showing you an example of it. Change shopping list 0, change item 1. All I'm going to ask you to do this week for this one is just change one or more items in your shopping list. 1 is the minimum that you need to do. You can do more than that if you want to, just to see how it works. But again, the catch on this one is just throwing out at the index of that array, whatever it might be, and then updating the text to be something different than what your original item is. And I suggest putting in the word changed in front of whatever it is you're going to be changing it to. That way when it displays later, you'll see what it's talking about. And by the way, we'll see in an end result. I did create an app for you to look at the final result. So that fulfills the changing shopping list. And then finally, the deleting shopping list item. Again, for a deleting function, you will need a position only, and that's it. It'll find, using it this .splice method in an array, find a position and deleting it. All right, deleting that 1 position and then displaying it. Lastly, you'll do 3 calls, and again, you can do more than 1 add shopping list here. You can do 10 or 12, whatever you want to do. But I would put in to ask when you add in an item, just to put the word add in front of whatever. So if it's a shopping list and you're doing groceries, it might be, add lettuce, add milk, add eggs, whatever. That way I kind of know what it is. Changing, same thing, just put the word changed in front of it when you're calling that one. And deleting, just need to delete 1. Okay, you can do more than 1 if you want to, but requiring only 1. For the adding, I'm only requiring 1, but I'd recommend doing more just to meet what you've been doing last week with your app. So that fulfills the requirement. Now I'm going to show you the final example of what it looks like. I did create a final plunker. In version 1, I didn't do this, but I thought it'd be good to do it for version 2 and on. We'll play this one, show you what it looks like and results. So there you go. There's the shopping list version 2, or I call mine shopping list 2.0. Got my initial 3 items, add the 4th, add the 5th, change item 1, change, then this one added item 6, changed item 6, and then finally on deletion, I deleted item 6 here, finally at the end. Make sense? So go over that, hopefully go over this slide by slide, create your own. You will need to use the code you used for version 1, just so you won't have to remember what you typed in. You can copy and paste stuff over, no big deal, into that. Now, you might be thinking, hey, can I do a version change like you did last week? Yeah, you can do that if you want to. I showed you last week in the steps how to do a version change, or not a version change, it's fork. Do a fork of your project. I think it's what I had you do last week, if I'm not mistaken. Let me bring that up real quick. I think I did. I think I did it on like slide 1 or 2. Yeah, the fork. If you wanted to do a fork of what you've already done in version 1 and then just modify it with the functions, you can definitely do that. You don't have to create a new one if you don't want to. Because remember, when you forked it, you just go in the description and name whatever you want it to be, the updated name. I'll pull mine up here real quick. So after you fork it, you'll just, your description will change here. And once you change that description after a fork, that's going to be the name of it. So if you don't have to reinvent the wheel, you can just fork what version 1.1 that you did last week, rename it on the description to shopping list app version 2.0, and then just add your functions if you wanted to do it that way. You don't have to, but if you want to. Forking I use all the time just because, especially in cases like this, I didn't require you to this time because I thought some of you might want to do it from scratch again, just to do it. But if you want to fork it, you can definitely do that. It's up to you. So you can either fork it or create new, either one. Questions on homework? So we're version 2, and just kind of looking ahead as far as where we're going next week, we will talk about the DOM for the end class for next week. We will add version 2.1 next week, and we'll be actually putting hooks in the website in the HTML part for DOM. We'll be putting hooks in there for DOM for like, instead of you calling the functions in your code to add the list, you'll actually be starting next week to call them within a list, a text box and a button. You'll be able to pull up your app, it'll have the 3 initial items, and then you'll be able to type in bread, add, milk, add, and you'll see your list actually show up as you add it on your website. Make sense? So start seeing a little bit fleshed out as the final example is for the plunker. Because the plunker is final example is going to be, went over that last 3 weeks ago actually. Pull that up real quick. I think it started in week 4. Not mistaken. It must have been week 5. Week 5, let's look at that. The end result plunker here. I'll put that in the discussion, maybe. Remember. Nope. I will find it. Let me log into my plunker here. Thought I had a link on the site, maybe I didn't. Announcements, maybe? Nope. Well, let me log into my Plunker. We'll do it that way. Okay. There we go, finally. I'll put a link there in the example. I know I showed it to you guys, I thought. Did I show you the final app? I did, didn't I? Am I just thinking crazy? Did I show you the final app? Okay. I showed you that, didn't I? Let me put that, let me copy that, put that in the final. Thought I had it in there, but that one not. Okay, so I'll run this for you. So, at my shopping list, the little red add button with a plus, purchased, and then a send list. The send list will be used on your phone to actually send it to a phone, text it to a phone, basically. So I'll put in here eggs. Then put a nice little checkbox there. I'll put in milk. And we'll put in butter. Stuff you get right. And then the thought is, right now I have purchased. I think I told you guys when I was looking at it more. I think I might just put added or something instead of purchased. That way, as you're going through the shopping cart, you can, check mark, okay, it's added to the cart, added to the cart, added to the cart, done, right? So when you get the list on your phone or you're sending it to somebody, it'll have everything above the add sign, which like say added or something like that. And then as they go through the store, they can add it that way to a list. That's it. And you can't go in here also and delete these one by one. And then this will be able to, I'm going to use an XML database to save the list. So what will happen is, after you've added whatever list that you want and you hit send, the send list button or list link is going to do two things. It's going to save it to an XML database just for you, a temporary database for you to be used. When I mean temporary, it's going to be overwritten, a unique link overwritten each time, a temporary unique link overwritten each time for your app, basically. So you'll have your own unique folder with your XML file in it. I will give you the hooks to use when we get there, and you'll just put it in your code. It'll write to that XML file, and when you send it to whomever, that link will stay live on their phone, basically. Won't go anywhere, and because it's just an XML file, and so it'll be unique to that shopping list. It's going to stay live on that phone. So when I say temporary, I guess it's a permanent XML link. I'm not going to delete them anytime soon. But at the end of the semester, I was telling somebody I'm going to give you all that code to where you can take it. I'm wanting to port it to like Dropbox or something. That way you can use that for no cost. And there is ways we can, with JavaScript, write to a folder in your personal Dropbox account into a folder in JavaScript, and we'll have to show you how to do that. But once we do that, you can basically log into your Dropbox.com account or create one. You'll get a development key. You'll have to put it into your code, and then once you have that in your code, you can share that list with anybody. And as you create those lists, it's going to create a new XML. And XMLs are like really small. It's not going to take up a lot of space. And what's nice about XML is they take up less space. They're really not meant to be secure, but they're very portable and they'll load on pretty much any browser. And that's what's nice about it. And it's easy to read an XML file as well. So anyway, that's the end result. What it's going to look. Yours will look a lot nicer than this one. This is just a bare bones one. You know, ideally have like a picture up there and some more, you know, make it look a little nicer on the background or something with some CSS. That's a bare bones of functionality anyway, what's going to happen. Questions on that? So that's what yours will end up looking like. Was probably much nicer than mine looks. So, all right. So questions on the homework before I let you go? All right. Well, good job. Oh, I want to do one more drawing. Let's do that real quick. Okay. For this one, I'm just going to have you guys, I'm going to number everybody. And let's see. I'm going to number you. Let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm going to run this 5 times real quick. And whoever wins the race gets the other iPhone holder, or phone. It's not iPhones, any phone. So you're 1, move, 2, 3, 4, 5. Here we go. I'm just going to tell you who won it, what you got for 1. When I tell you your time, just keep it. I'm not writing it down. It helps to actually time it, doesn't it? Okay, let's do that again. There we go. Go. .39 moves you. 7.39 is number 1. Number 2, you're getting there. But it jumped a line. Uh-oh. Oh, man. 10 seconds. Sorry. All right. Number 3. .3 seconds. Number 3. Number 4. .12 seconds. And number 5. .48. So who got the lowest? All right, come on up. It is yours.
Sweet.
Yeah, I'm gonna bring some more next week too. I'll have fun with it. There you go. Yeah. Yeah, that was freshly printed on a 3D printer, so we'll be making more of them. Huh? No, I actually have one at the house. I printed it at the house. Yep. We have 3D printers right on both sides over here. And at the robot event last Saturday, we printed up maybe 8 or 10 of them for kids that came in, the students that came in and helped. Oh, by the way, it reminds me, if you've not been to the Learning Robots, we have a next one coming up March 25th. We had a lot of fun Saturday. What we did was after the robot event, where you learn basic coding with robot, you get the robot, you have to pay for it, but you get to take home. We went out in the foyer here, put big pieces of paper out on the floor, and the kids went just in groups, did humongous lines. I'm talking like 6 to 8 foot lines of code with the little robot. And so they had a lot of fun. I think they had more fun with that than working in here on the computers, which had a lot more fun out there. I couldn't have gotten the floor like that, but they had a good time. And so, but anyway, you might tell folks about it. The news covered it, I believe. And so March 25th is the next one. They can register by just going to myrc.org or rockefellercollege.edu, either one. And we do have the next hour of code coming up Wednesday, March 1st at the RBC downtown location. And we've still got about 3 seats left on that one. If you've not been there, even if you've been to Hour of Code before, which I know a number of you have, that's a great location if you've not been there, because we're doing it in the PC lab, which seats like 28, and it's on the second level of the R Star building. It's really nice, really impressive space, I think. And you can park right in the R Star parking lot. And so yeah, a lot of good things coming up, and so hopefully get more interest in the community with coding. We're already starting to. I think the meeting Saturday will probably open up the doors for like the Rockford Public Libraries. I think we're going to be going into those, and maybe possibly even the locations on the Cherryville Mall we're looking at, and then Barnes and Noble we are going to be at March 30th for the Maker Fair, mini Maker Fair. So a lot of cool stuff coming up. So anything you guys can do to help or spread the word, that'd be great. If nothing else, just retweet and repost on social media is definitely helpful. So, all right, that's all I got tonight. If you need help, come up and see me. Otherwise, see you next week. Enjoy the weather. Wednesday's supposed to be another record breaker, 70 degrees. Crazy, right? I'm liking it. I'm liking it. All right, you want to come up here real quick and I'll show you what we need to do, or at least give you a 5-minute, here's what's going on type thing. And then I'll probably ship it off to you when I get home if you want to work on it. So, okay, so let me put all this stuff away. Hey, we'll see you, buddy.
So, and are we good to have interview also?
Do what now?
Interview?
With Joe, with a...
No, the one Periscope.
On Periscope? Yeah. Actually, that one, yeah, because are you here Tuesday night?
I have class.
What time?
3 to 7.
3 to 7. Let me see what I have you down for. So I think I put you down somewhere. I don't think I have you this week. I have Andrew this week, but let me look here real quick. You might be right. I might have you this week. Let's see. Alrighty, let's see. Moo, you are. I have you down for 2:21. So what time do you got a class, you said?
3 to 7.
3 to 7. Where's the class at?
Jacob Center.
The Jacob building?
Yeah.
Trying to think. Would it be possible for you to come to this lab right after the class?
Yes.
Because I don't have my equipment with me, that's why I'm asking. So.
Oh, wait. I have another class after that.
What time? Because I have a class in here that starts at 7:30.
Oh, 7.
So I'd want to do it like, in between that class and your next class. So is your next class start at 7:30 on Tuesday?
Let me check.
Yeah, go ahead and check. Yeah.
Because
Go
I
for
have
it.
another class after that with Miss
Emerson?
Sylvia.
Okay. Well, look and see what you got schedule-wise, and we'll work it out. Okay. Not letting you submit it? Oh, right up here. That's for the in-class. Yeah, just put it down in there. That way I know I can go back and read. Yeah, that's all you got to do. Cool.
Okay, now I'm behind.
Okay. All right. Oh, yeah. No, you wanted to let them know about it. All students. Yeah, I'll be quiet. Well, just get it in and let me know when you got it done. Shoot me an email. I'll do it. Fine. No big deal. No big deal. So what time is it on Tuesday?